So this is the Chapter 3, Part 2 review for your midterm, and it's on motion. It's finishing up acceleration and graphing. So number 10, what is acceleration? First, what is the definition of acceleration? It's the rate of change in velocity. What's the formula? Acceleration equals the quantity of the final velocity minus the initial velocity, that whole entire quantity divided by time. And is acceleration a scalar or a vector? It is a vector. Number 9, given a scenario, how do you determine the direction of the acceleration? So as an example, if the object is moving to the right and speeding up, what is the direction of the acceleration? The acceleration would also be to the right. If an object is moving to the right and slowing down, what is the direction of the acceleration? The acceleration is to the left. Number 8, can you interpret an oil drop ticker tape diagram? What do the following oil drop diagrams or ticker tape diagrams represent if the object is actually moving to the right? So the first one, it's constant velocity. The second one is also constant velocity. If we're comparing the two, the top one is faster and the second one is slower. And then the third ticker tape is speeding up because the spacing between the dots gets spread farther and farther apart. Number 7, can you calculate acceleration? First example, a car accelerates from 0 to 60 miles per hour in 4 seconds. What is the acceleration? So you take V final, which is 60 miles per hour, minus V initial, which is 0. Subtract those, divide it by the total time, which was 4 seconds, and you get 15 miles per hour per second. Second example, a car slows down to 32 meters per second to 8 meters per second in 4 seconds. Calculate the acceleration. So V final is 8 meters per second. V initial is 32 meters per second. So you're going to take those, subtract them, divide by 4, and you get negative 6 meters per second squared. And it's going to be in the backwards direction because if you assume the car is moving forwards, the acceleration has to be backwards because it is slowing down. Number 6, on a PT graph, be able to identify different types of motion. So at rest, it will be a horizontal line, but it can be anywhere as long as it's horizontal. Constant speed is going to be a diagonal line. Our examples here, the blue is fast at a constant speed and it's a positive velocity. Purple is slower, it's still a positive velocity. The yellow and red are both negatives. The yellow is slow, the red is fast. Speeding up, down here, red is in the positive direction and it's a positive acceleration. Blue is in the negative direction and it is a negative acceleration. Slowing down, we've got red here in the positive direction and that is a negative acceleration because it is slowing down. And blue here is in the negative direction and that would be a positive acceleration, negative direction. Slowing down is positive acceleration. Number 5, what are the 2 ways in which positive acceleration occurs? So for positive acceleration, positive velocity and speeding up, and negative velocity and slowing down. And then for negative acceleration, we need a positive velocity and slowing down, or a negative velocity and speeding up. Number 4, on a PT graph, what does positive velocity look like? And what does negative velocity look like? So positive velocity is anything with a positive slope, and negative velocity is anything with a negative slope. Number 3, we did not cover in the fall of 2020. Number 2, we did not cover. Number 1, what does slope represent on both types of graphs? Well, we only covered position time graphs, and the slope is the velocity. So that is the summary of Chapter 3, Part 2 for your midterm review.